Bismillahirrahmanirrahim. Assalamu alaikum. My name is Professor Dr. Rizwan Jamil Qureshi. Welcome to the lecture number 5 of Software Engineering 2 or Advanced Software Engineering course. And topic of coverage is security assurance. Any question about the last lecture? Mr. Hussam? He is the only one present during this lecture. So, no question. Security assurance is achieved by vulnerability avoidance, attack detection and elimination, exposure limitation. Vulnerability we already covered in the last lecture that it's a weak security. That means there are loopholes in your security from where hacker can penetrate. So system is designed so that all possible vulnerabilities are identified and try to fix those loopholes by minimizing the damage of the attack. So, for example, your network is not connected to internet, only LAN is there. Like most of the accounts department, they don't have internet connection. So by achieving this, you can avoid the vulnerabilities. Or the case of Stuxnet, even the LAN was not connected to internet by USB, Stuxnet was spread because the hackers know that Iranian scientists will use their laptops and USBs to transfer the data from their laptops from home computers or to laptops to office computers. But this rare case, most of the cases you can avoid that. Secondly, attack detection and elimination. Once your system or your servers are under attack, you need to identify what kind of attack is there and try to fix those bugs or loopholes in your system. Like the case of Stuxnet, Iranian scientists detect the attack and control that. The third thing to assure security is to exposure limitation. By minimizing the exposure to internet, by having firewall, by having antivirus, you can minimize your exposure to internet. And that's the reason the most of the banks, they have backup policy. They made backup 3 times a day. So in case of damage, the important information, the valuable information can be restored. Next topic is reliability metric. We already covered reliability, that your system should have minimum bugs or your software should have minimum bugs and it must not crash, it must be stable. So how we estimate the reliability? So there is a metric, mean time between failure is equal to mean time to failure plus mean time to repair. That how much time, mean time, the average time of failure and average time to repair, if you add them, you can find the mean time between failure. That's the reliability. Then availability metric. Availability means your software should be available to the users 99.999%. Without failure, its functionality should be available to the users. So how much time your software is available to the users to perform its functionality without failure? So availability is equal to mean time to failure divided by mean time to failure plus mean time to repair multiplied by 100. So that's the availability in percentage. Usability. Easy to understand, easy to learn. there are several dimensions of dependability. There are 5 dimensions: understandability, learnability, operability, attractiveness, usability, compliance. So how much it is easy to understand a software, that's called understandability. Then learnability, how much it is easy to learn. Operability, how much it is easy to operate and control. Attractiveness, how much users are attractive to use. Like for example, Windows usage is 99.90% of the entire market, whereas Linux, Unix are covering 2 to 3% of the entire market, because users are comfortable, users are more attractive. So capability of the software to attract the user is called attractiveness. So if it is easy to use, easy to understand, easy to operate, then it's attractive for the customer. And you have done UXT. So what is UXT, Mr. Hassam? Yes, user experience design. The users were involved while designing the software. So usability compliance, how much conventional standard styles and standards are applied to design the interface. For example, title bar, tool bar, menu bar. So we have a metric to calculate the usability: number of functions understood by the user divided by total number of functions, so that you can calculate the usability. Portability, how much easy to run a software on multiple platforms. So we can calculate the degree of portability is equal to 1 minus cost to portability divided by cost to redevelop. So you have parentheses, brackets are there. So 1 minus cost to portability divided by cost to redevelop. How successful we are developing high quality software. The quality of product. What is quality of product? Yes, Mr. Hassam. Quality of product means how much it possesses quality attributes. So quality attributes should be achieved to have high quality product. Then quality of process. Under the quality of process, we have quality standards and the standard methodology. How much quality methodology, the process model you are following to develop the software, and how much quality standards you are applying on the development process. So for example, standard methodologies like waterfall, spiral, agile, XP, Scrum, rational unified process, agile unified process. So these are the standard methodologies. How much you are practicing them. And then quality standards. How many quality standards we have for the software, Mr. Sam? We have ISO and CMM. ISO is introduced as a quality standard for all products, for all organizations. How many type of organizations we have? Yes, Mr. Hassam. We have 2 type of organizations. We have profitable organizations and we have non-profitable organizations. That's from the profit point of view. But actually, we have product-oriented organizations and we have service-oriented organizations. The companies who have products, so they are covering manufacturing industry, construction industry, this all, or software development industry, STC in Pakistan, PTCL, Saudi Electricity Company, software development companies like Microsoft, Apple, Google, in Pakistan, NetSol, Tower Tech, Five River Technology, Descon, IT24, and so on. Or my students' company, InvoZone. And then service-oriented, like Toyota, Honda, Suzuki, GMC, Ford. These all car manufacturing companies, they have products like Honda, Civic, City, Accord, Toyota, Corolla, Camry, Yaris, Prado, Land Cruiser, Fortuner. Same company have service-oriented organization as well, service-oriented department. Like Latif Jameel in Saudi Arabia is a official distributor of Toyota company. So Old Makkah Road, they have showroom where they have products. And parallel to that, opposite to that building, they have service center. STC has products, STC has service, has its services. So if you have some problem in your Wi-Fi or any other STC devices, you call them, you complain them on 900, and then report is written, and then you receive complaint number. After a couple of days, you will receive, within 48 hours, you are assigned a technician with a code, service code. Or Cisco has products, and Cisco has service-oriented organization, the service department. ISO has introduced different standards for products and different standards for services. But for software development, they have one standard, the ISO 9000, and it has different versions, version 2000, version 2008, version 2015, the latest one is version 2018. That is applicable for software development companies. Only one standard. Then it has 20 clauses, and every country has a local body, the certification authority, to assign you certification that you have achieved as a company, ISO certification, or you are ISO certified company. Like Moody is responsible in Pakistan, but with the local body, with the local people. In Saudi Arabia also Moody is there. In other countries, Dubai, Moody is there. So after that, once you achieve ISO, you go for CMM, because ISO is a prerequisite for CMM. CMM is introduced by an American university. Its name is CMU, Carnegie Mellon University. MIT, Massachusetts Institute of Information Technology, is the #1 university in IT. Same like MIT, CMU, Carnegie Mellon University, is the #1 university in software engineering. It has a department, SEI, Software Engineering Institute. SEI has introduced CMM standard. CMM stands for C for cat, M for monkey, M for Mona Lisa. Am I correct, Mr. Hassan? No. Capability Maturity Model. It has 5 layers, 5 levels. If you achieved ISO, you are at level 1. And each level 2 to level 5, we have KPAs. K for king, P for parrot, A for apple. Mr. Sam, am I correct? No. KPA stands for key process areas or key process area. These key process areas are estimated against KPIs. What is KPI? K for king, P for parrot, I for ink. King and parrot are fighting for the ink? No. Key performance indicator. For example, let's assume level 2 KPA, how much standard methodology a software company is practicing. This KPA will be evaluated against the KPIs like how much it is time saving, cost saving, effort saving, resource saving, efficiency of the company, and so on. So each KPA is evaluated against KPI, and there are several KPIs for each KPA. It's indicator. Then there is a local body for CMM. No, CMM is totally controlled by Software Engineering Institute. So if you want, as a software company, you want their visit, you inform them that we have started KPAs of level 2 and we have achieved level 2 KPAs, visit us. So you have to book an appointment like 1 year before or 2 years before. So after that, because only one body is there and it is covering all software companies of the world, there are only approximately 300 companies all over the world who have achieved level 5, which is the highest level of CMM, including the Microsoft, and then in Pakistan, Netsol company and NCR company, which is very popular for ATM machines, and Teradata, which is a data warehouse. So that body from Software Engineering Institute will visit you, so you have to pay their visit charges, inspection charges, traveling allowance, traveling expenses, tickets, hoteling expenses, and this body, this committee will stay with your company for 1 to 2 weeks. So 4 or 5 people will be there, and each will sit in one of the departments, like with the programmers, with the development department, with the testing department, with the architect department, with the configuration department, and they will visualize, they will see, they will observe that what you are practicing, you are documenting or not. If they are satisfied, they are happy, they will issue you that you have achieved level 2 of CMM certification. And same you have to repeat for level 3, level 4, level 5. So it's assigned you not for lifetime, like 2 years, 3 years for level 5. After that, they will pay you another visit. Recently, Software Engineering Institute has upgraded CMM with the CMMI, Capability Maturity Model Integration. Now instead of 5 levels, one more level is plugged, it's called level 0. So if you achieved ISO, you are at level 0, not at level 1. So you have to achieve level 1. In detail, we will cover inshallah in the upcoming lectures. Then the third thing that you have achieved high quality software is the quality of product in the context of business environment. Mean how much your product is profitable in terms of ROI. R for rat, O for ox, I for ink. Return on investment or return over investment. And we have a term, it's called BEP. Yes, Mr. Sam, what is BEP? B for ball, E for elephant, P for parrot. So elephant and parrot are fighting for the ball? No. Break-even point. Break-even point means at what stage your product will cover your initial cost, your investment. It could be after 1 year, and then according to the money value after inflation, after depreciation, what is the value after 1 year equal to that money. So once you have achieved that money, what you have invested in the business or in the software, like SAP, one module cost is 9 million riyal, and 2 to 3 million licensing cost and 2 to 3 million training cost, equal to that money after 1 year. What is the money value after 1 year? Equal to 12 million riyal, 13 million riyal. That is called BEP, that you have achieved break-even point, and after that your profit will start. That's ROI. Then chapter 10, Sociotechnical Systems. We already discussed that what is a system. That system is a set of interrelated components working within a boundary to accomplish or perform some specific task, like car, human body, this universe, this world, King Abdul Aziz University. And then you have information system. Information system is a collection of hardware, software, data, people, and procedures. So there are 5 components of information system. These 5 components work together to process information to run a company or a business. That's called information system, like ATM system, inventory system, payroll system, procurement system, library system, and then in King Abdul Aziz University, we have registration system, orders, plus weather forecasting system, traffic control system, flight control system, aviation control system, fire alarming system. So there are several systems. We are surrounded by the systems, information systems. Sociotechnical systems has a stack of layers: society, organization, business processes, application system, communication and data management, operating system, and equipment. So these are the layers of socio-technical systems. Equipment include hardware, devices like computers, servers, embedded systems, or embedded systems need hardware. Operating system like Windows, Linux, Unix, Mac. The communication systems or data management, middleware software like APIs are there. Application system, the applications which are running on the top of operating system. Then business processes, the business logics, business rules. The organization which has strategic objectives, mission statement, goals, and the society, the laws, rules, regulations, the culture that affect the operation of the system. Socio-technical system has some characteristics. Yes, Mr. Hussam. There are 3 characteristics. Emergent properties. The properties of the system depend on the system components and their relationships. Non-deterministic. And third, complex relations with the organizational objectives, the company's objectives. Let's talk about emergent properties. Volume, reliability, security, repairability, usability. Reliability, security, repairability, usability, we already have discussed in the previous lectures. Volume of the system means how much its size is increasing. And when size is increased, what is the effect, cause and effect? Mr. Hassab, its complexity increased in terms of integration of the components, in terms of data import and export, Then there are type of emergent properties. We have functional and non-functional. Functional, which are related to functionality of the software. For example, ATM, withdraw, deposit, cash, transfer cash, check balance, pay bill. These are the functional properties. Non-functional, which are quality attributes like reliability, performance, safety, security. These all are non-functional emergent properties. Non-deterministic. Non-deterministic mean we are not sure what are the possible outputs of the system because we are not sure about the inputs of the system. Like human interactive system where human interactions are there, you don't know what kind of input human will press or will pass to the system. Deterministic, we know these are the possible inputs and these are the possible outputs. So sociotechnical system will not always produce same sequence or output like the deterministic systems because of human element. Because people do not always behave in the same manner, they behave differently, they react differently. Or the changes in the system like hardware, software, data, procedures. There are several disciplines involved in socio-technical systems like architectural, electrical, engineering, mechanical engineering, software engineering, civil engineering, electronic engineering, and so on. So system engineering is involved in all disciplines. All fields are involved and they are used in all domains. And when you have integrated systems to work in different disciplines, you have some difficulties like communication difficulties, differing assumptions, professional boundaries. So communication difficulties in terms of terminologies like civil engineering, electrical engineering, mechanical engineering, software engineering, terminologies are different. And different assumption, each discipline has its own assumption which cannot be done by other disciplines. So there are constraints, there are limitations. And each discipline try to protect their professional boundaries and expertise. Thank you very much. Jazakallah khair. May Allah bless you. Assalamu alaikum.